In this video, we're going to create Mendelbrot fractal art and we're going to use Fragment shader in Flutter. And this is a quick video how to use Fragment shader in Flutter, not how the Mendelbrot fractal is made. So let's jump into it. For that, I will open my Visual Studio Code and press Ctrl+Shift+P. I will search for Flutter and we can have it like this, Flutter new application, and from here I will select the empty application and we need to set the destination folder, so I'll choose it here. And now you can name the project whatever you want. I am using Mendelbrot. After it is done, it will take some time to generate all this file. So yeah, after it finished, it will look something like this. It's a beautiful hello world application. We don't need it, we'll just cut it here. So first let's define our fragment shader. I will create a folder assets and in here I will have another as shaders. And in these shaders I will create a new file and I will name it mendelbrot fractal.frac. Let's go to our perspec.yml and reference this fragment shader. I will write shader and provide that path here. First, let us create a simple fragment shader to verify our setup. I will open our fragment file and in this fragment shader, I will create a simple fragment shader. So first of all, we need to define the version and we need to include the Flutter lib here. And we'll pass a size, our canvas size from the Flutter app, and we'll return a vector for fragment color from it, which is RGBA. And as like others language, we need to define our main method. And in here, we will get the Flutter coordinate xy and we'll divide from the usize and we'll create a vector3 color. If you are thinking why I am not passing the 3 argument for vector3, it's called swizzling. You can pass one and the other argument will think we're having the same one. If we pass 2, then the third argument will take the second one. Let's update our color with the UV and we'll use the XY and pass the UV here. And let's refine our fragment color. So it will be vect4 color and f1 for the opacity here. And this code seems quite just a text, so you can use GLSL extension from here. I will enable for this workspace only. Let's get back to our main.dart file and I'll replace this with the material app. And for home, I'll create a Meldelbrot fractal page. And we also like to disable the debug mode banner, so I will call it here and set to the false. So let's get to here and we will copy this name and press stateful and press enter and we'll just paste it here and we will create our stateful widget. Now we're good to go. Now we will load the fragment shader. From our fragment file, we can get a fragment program and it will be a feature, so we'll define it here. So we will define our load shader method and we'll get from the fragment from assets and it comes from the Dart UI. Now I like to use the feature builder and for that I will create a program feature variable for this load my shader. I'm gonna replace this container with a scaffold and on body I will use a feature builder. In this feature builder I will provide the program as a feature here. And for the builder we can have a different state based on the snapshot. First we can have a error. If it is error, just return the text with the error. If we don't have any data, it's mean it is loading. And if it is all passed, if it has no error and it has data, then it means we are good to go. So I'll return a custom paint from here. Why we are using the custom paint? Because to render a fragment shader, we need to use a custom painter. I'm going to create a class name as mendelbrot fractal painter and it will extend the custom painter. For the custom painter, we need to override two different methods. One is the paint where the beauty will happen, another is the should repaint. We will return false from the time being, and yeah. For this custom painter, we need to pass a fragment program. We'll create the constructor and we'll pass it here. And from this custom painter widget, we will use the painter and we'll use that Mendelbrot fractal painter, and for the shader we can pass this shader here. And for the child we'll use size expand. It will just take the size as much as it can get. From this custom painter we need to pass few arguments on our fragment shader. As we can see, we have a U size, so we'll pass it from here. First, let's get the shader. I will create a shader variable and get the shader from program.fragmentShader. Now we need to draw the canvas. So I will use draw rect. For the rect, I will use from LTWS, left of width height. And for the left and top, I will pass 0, and for the width and height, I will get from the size. And then I will add the shader. For that, I will add paint.shader equal to our shader. Now if I do a build, I will select Windows as my build system, and if we get this output something like this UV color, then that means our setup is okay. Now we will create our Mendelbrot fractal art. Now we'll get back to our Mendelbrot fractal fragment file and we'll create a method to render the Mendelbrot. So first we'll need the max iteration, how much depth we like to have it here. Then I'll create a Mendelbrot function. It will return a float and it will take a vector2 as the UV. First, let's define a constant here, and this is the setup for initial position. We can tweak it here. I don't know it much better, but this works. And then define our z function. And we need the iter float variable, and let's create a for loop here. We will go through until the max iteration, and this is our Mendelbrot function here. And if the dot product is greater than 4, then we will divide the iter by the max iteration, and we just increment it and end of the time, and if nothing happens we'll return 0. So now let's go to our main method. I will create a float variable sm and use our Mendelbrot function here and pass the UV. Then I will add the Mendelbrot on the column, and from the fragment shader I will return this column and then 1 for the opacity. You know the swizzling. First 3 color vector3 will get from this one. Okay, we're having kind of UV color, and it is because we have this UV line here. So we can remove this line and it will be fixed. Now we will have our black and white Mendelbrot fractal. This is quite it, and it is beautiful, and let us improve a little bit here. In order to colorize the Mendelbrot fractal, we can create a method here. Maybe name it a random color and return a vector3, because for the alpha channel we will pass 1. So it will take a float and it will return a RGB, and this is quite a random thing. You can play with it. I used AI to get a better color. It seems we had a typo here in this return, so yeah, spell it correctly, and we do a hot restart. It will do by default and we will see this beautiful thing. And let's zoom it. We can wrap this custom painter with the interactive viewer. For the main scale we can have 1. For the max scale we can have 1000. Now we'll use the mouse and we can zoom a little bit. And this is quite beautiful. And I think I like to toggle between black and white from this Flutter side. So for that I will take another float variable because it's a single variable. So we'll use uniform float and let's name it colorized or is colorized, anything whatever you want. Also we need to pass it from our canvas. So I will go here on the custom painter and create a bool variable is colorized here. And I don't like to have a multiple positional argument. Here I'll use the name argument with a default value is equal to false because black and white is a good thing. And we'll pass it the set index to because first two vector, first we had vector true and now we have just a single float. Yeah, that's why it is index is true. And if it is colorized, we will pass 1, else it will be pass 0. Something like we are just tweaking the true and false for the boolean. And we can change this covariant here and we can check if the old elegant is colorized is not equal to colorized. So then we'll update this custom painter. So this is good to go, and we need to create a state bool variable for this. So let's create a bool variable is colorless and by default it will be false. And let's create a floating action button here. And in onPressed, I will just update this true to false. Also, we need to call the set. Let's see without it. And let's pass this boolean on our custom painter. So we're done with this size. Let me bring the UI properly. Yeah, this is good. We have our colorize button here. So let's go to our fragment shader. In here I will create if our colorize this variable uColor, if its color is greater than 0, we'll use this random color here, else it is black. So we need to pass another thing here and it will be our color. And let's use the power for a better view. So I'll use the column and vector 3 will be 0.45 kind of gray color. I think I made a mistake here. Yeah, I need to add the col plus equal to n. And now if we do a hot restart, it looks good. And if I click it, it's not working. I forgot to call the set. Now let's press it here. We can see it toggles the color. And this is quite good. I like it. And our zoom is working fine. So there are a few things we can do here. And here we can play with the constant to change the position. We can always increase the max iteration and our zoom level, but be sure that it takes your GPU to render this thing. I have quite a good GPU and so I'm okay with it. So I like to add a zoom out button, so I will return the row from this floating action button and add another zoom out button. And for the child, on last button, I'll add icon as zoom out so that I can identify from the UI. And we can go to our interactive viewer. We can see we can pass a controller here. And this is a transform controller. So transformation controller. We don't have it yet. Let's go at the state class and create this controller. Let's dispose this controller. And on the next fab button, I'll use it. So remove this thing, controller. We don't have any animated option, but we only have this value. So we'll pass the identity matrix here. The row is having on this position. I will use the main axis size to the main, and maybe we can also change the floating action button position to the center. This center dock. This looks good. Now let's zoom in. Yeah, this is quite beautiful. I'm lost. I'll click this button and it will zoom out. So yeah, this is what I wanted to build, but I wanted more than this, like infinite one, but it is hard to calculate the infinite one. And at least I don't know how to do it. If you know how to do it, please let me know. Anyway, thank you. Keep playing with it.